Yeah, hi guys. My name is Bagus. I am your host today. I am now back in the place I used to work at Imperial College London, and here behind me we have this setup here. And then, as you can see, these are layouts of our exhibition where we talk about termites' nest. It's kind of crazy because back when I was at Imperial College, I wasn't a biologist. I was an earth scientist, and we were talking about how to get oil out of the rocks and all those questions native to earth scientists. Once upon a time, the problem came to surface, and it's about how precisely termites are able to build super architecture. So termites typically found in Africa or in Indonesia where they eat your furniture. So what you don't know about it is that they build super architecture. So the nest where they live, they have massively good property in regulating temperature, regulating moisture, regulating CO2 exchange. Everybody sort of know it, and everybody tried to mimic the way they make buildings with the way termites make buildings. But the question is how precisely they did it. So it's a massively interdisciplinary work, and then this is a termite. If you can draw closer, that's okay. It's still alive, right? So that's a termite's nest typically, and if you can see the structures that is left over by the termite as it builds its way towards the end, the center of the termite, it leaves the porous structure, and somehow this has tremendous utility. This termite's nest are able to regulate its own temperature. I guess the question is, how do they do that? Did God tell them to do that? Because they're able to do that not only by themselves, they do it collectively. And these are the big questions you try to find out, and it really satisfies. And here with me is Dr. Ali Q Raeini, and he's a coding guy. He's a programmer, right? I mean, none of us were biologists, but Ali's been doing research simulating the way fluid moves through termites. To porous rocks.
Yeah, and heat.
And heat. Okay. So what we did was actually implemented what we knew in the context of something completely different. That's on the termite's nest. And the paper gained a lot of traction. It was published by a publisher of Science, which is one of the most, if not the most prestigious journal in the world. And it's one of the most satisfying time as a scientist, really, because you don't think about the nominal value of it. You're just driven by what? Curiosity. What do you think?
Yeah, it looked like kind of a project which doesn't have much financial value, but it turned out to be kind of much more interesting than those projects we funded to do.
So why were you stupid enough to do this, regardless not being paid?
Well, it's human nature.
It is human nature, guys. So to young people out there, we're thinking about aspiring to be Ali. Right. Follow your curiosity and your dreams. And then, someday it will lead to something important to explore. Ciao, ciao. Say bye to Indonesian people.
How do I say it?
Sampai jumpa.
Sampai jumpa.
So Kamal here is the protagonist of this whole research. And then he's here now to tell us how exactly the termites do it. So what do you think? Okay, first question. What makes you do this sort of work? And can you tell about what this work is all about?
So we are basically from engineering background. So mostly petroleum engineering, do a lot of subsurface engineering, CO2 storage. But we somehow got connected to people in France through Bagus. And they are biologists. They're looking into problems like this. And this is a very fascinating problem. For example, the temperature outside in Africa, it can fluctuate. On India, it can fluctuate from 40 degrees in the day.
Yeah.
In the night, it can be 10 degrees centigrade. But if you look inside, not underground, because it gets buffered underground. Yeah. It can be within plus minus 3 degrees centigrade throughout the day, throughout the year.
Very stable.
Very stable.
Right.
And that's very fascinating because it comes only because of the structure of the termites itself.
Yeah.
And you can think about, okay, the termite, they're blind. How can they make structures, beautiful structures, which are so useful? And also the ventilation, they have awesome, like self-sustaining ventilation. And that's very fascinating to us. And there are a lot of open questions, and this is our background actually. We are doing a lot of research in porous media research, looking into how fluids move into the rocks. works, how the oil gets out of it, how we can store CO2 underground.
You're not biologists, right?
Not yet.
Not yet, right. But why are you fascinated in this type of research?
Because you can link, first of all, you can link easily what you see. Second is helping society. Helping society in way designing energy efficient buildings which people can live without using so much energy. If you can save 70%, 60% of energy what we're using now, just simply changing the design of the building.
Yeah.
That's, I think, the biggest success we have. That's the fascinating part for us.
Take us to what you did here. So what are the things you did to get all these conclusions?
So it's done by our group, which is part of group is here.
Yeah, it's us.
Yeah, us, 3 us, and then Pierre has left. So the interesting thing what we had, so these are the nests from Senegal. One is from Senegal, one from Guinea. They are from very different area because let's say this is sandy area. This is more clay. And why is clay? Because it's more green. It can have more moisture containing properties. But when you look into structures, inside the structure, they are the nests from the same places. But we did scanning with the medical CT scanner. If you look into structure, they look very similar. The yellow here is empty spaces.
The yellows are empty spaces, right?
And the red is the solid part, which could be, if you see this one.
Ah, there you go.
This is the empty space here. And this is the red part, what we see here, red. You can come here back, and red here. The question, there are a lot of open questions here. For example, in this particular species, they don't grow fungus. And people, what they believe, the whole thing is blocked. And it doesn't make sense because there are millions of colonies living there. They produce a lot of carbon dioxide.
Right.
They have to exchange the carbon dioxide. How do they do it? So what we did,
They have to breathe.
they have to breathe actually, otherwise they would die. So what we did, we took a lot of samples from this side, cut the wall, and looked into very high resolution X-ray tomography with 1 micrometer resolution.
Right.
And this is how it looks like. This is only, let's say 2 millimeter across. The blue color here is the empty spaces. And it turned out to be, first of all, as we thought, it's all porous. There must be some empty spaces which can allow ventilation to go through.
Right.
And that's what we found. There's empty spaces, they're all connected. But we found something very interesting, more interesting. The pores, what we call empty space as pores, and the pore sizes, it can be like different types of pore sizes. We have 2 different types of pore sizes. What it means, when the termites, when they bring the soil, how they make all the things structured. So they go around, they collect all the material, soil, clay, wherever they are, when they find material, they put the saliva in, which works as a cement.
Yeah, and the secretion too, right?
Secretion, exactly. Secretion.
Cement them all together.
Exactly.
Right.
2 things together, and then they squeeze in the mouth, and when they squeeze things in mouth, there's a sand particle. They collect together. It's very similar when you make a sand castle on beach.
Yeah, my kids do that. Yeah.
So you have the empty spaces between. When you put anything together, like grainy pot, you have empty spaces in there, and that's what you see, empty spaces in the grains. But interestingly, and termites, they bring 1 pellet together, another here, second, third, fourth. They keep putting on together, but by nature of this, packing geometry, you'll have empty spaces between the pallets. And this is what you see, the big spaces. And we found it very fascinating. Then we thought, okay, we found this one. What's the use of it?
Okay.
Can it be useful? It's just like by nature it comes and then it's...
So we know it works. We know it works. And what you did is you show why it works.
Exactly, yeah.
Right. What next then?
So we started doing simulations and turned out a very interesting part. Let's say we want to address the question of ventilation.
Yeah.
What happens? So you have airflow. We have a lot of field data available.
Yeah.
How much the airflow goes through. So no airflow, sorry, wind speed. You put the wind speed outside. With that wind speed, how much pressure drop can create?
Yeah.
Whether it's sufficient for the ventilation to happen.
Yeah.
And we found it works. But the interesting part that if there's no wind flows,
Right.
would it work or not? So we did simulations, and then it turned out to be the larger soils, they help in ventilation without wind flow, because let's say if you have CO2 concentration here less, and there's a large, things will flow to equilibrate. And
I got a question. It's more on the nature of this type of work. Well, you know this. I mean, we work together, right? None of us were paid to do something like this. I mean, we were earth scientists. I'm a mathematician by background, right? And then we were not paid to do this. We did this anyway. Now this paper is in Science Advances, right? One of the top journal, and it's gained traction from Le Monde in France, Compass in Indonesia, New York Times, right? So it's people like it. So I mean, it's an interdisciplinary work. What do you think? Is it important in the future that you work with people from different backgrounds or disciplines?
I think absolutely that's the idea. That's the whole theme. The one beauty what we have, we got a lot of mathematicians, biologists, engineers together now.
Everyone.
If we have addressed the issue in a systematic way, we find the answer, then it's all definitely useful. The whole idea is to design energy efficient buildings, learning from them.
And it's also international, right? You're from India.
Exactly.
I'm Indonesian. This guy holding the camera is a refugee.
From Iran?
From Iran.
He's from Italy, I guess.
Yeah, and we're like 7 nationalities.
So we have Pierre from France, Guy from France, and also the institutes, French institute involved, so UK. This is the key point. So we have diversity in our.
We have diversity.
Exactly. And diversity in terms of like geographically. Diversity in terms of knowledge, because we are different mathematicians, engineers.
Right.
They come with a different background, mindset. But the good thing is now we have same goal, and that's we will really do hard work to achieve this from different point of views.
One more question. Now, watching here are some Indonesian. Do you have any message for the Indonesian scientists aspiring to be, scientists like you, who have paper in really prestigious journals? What should they do? I mean, interdisciplinary research is expensive. It's not easy to do. Is it important?
Absolutely. I think the key point is like the research will develop from whatever environment you are. Let's say
wherever you are.
Exactly. Let's say we were lucky, we could image everything. That doesn't mean, somebody from Indonesia or India or Iran can't do something, because it depends on the environment where they are. But you need to have a good mindset up and good knowledge, good collaboration. Openness. And also you can send email to people who are very well established. And people are these days, they're very well connected, and they like to help promoting the research. And people should have mindset up to promote research, science, and humanity, I would say.
One more question before we end this. This event, the whole event, is about engaging public and getting to know more about science, right? We're in the UK. People kind of do this a bit more sophisticatedly here. Do you think the same other places in the world should follow this type of practice?
I think absolutely. Public engagement is very important, because sometimes public, they ask very basic question which we never thought about, to be honest. For example, here is still fine. When I gave first my talk, I got very questions which are basic. I never thought about that. And they gave me very nice, interesting ideas which I read about tomorrow. And also here, people are asking. First question was, do you think the termites are smart? Smarter than humans, or they are stupid, for example. So this is a question which is difficult, right?
And we do have the responsibility to provide answers.
Exactly. Right. There's millions of questions from basic root. You can, for example, how long they live, right? And if they live for 10 years only, why they design such a building which takes years to build? Do they pass it on to next generation? Things like that. Because these are not engineering questions; they are very basic questions.
It's just life question.
Yes, indeed.
This is our responsibility, guys. You know what fascinates me? I mean, it's not about getting oil out of the rocks. It's not about the nominal value. It's about making the world a better place. I mean, this is driven by curiosity, wasn't it? Right?
And this one, I think, research like this one, it should motivate other people to jump into research like this one, which is multidisciplinary or interdisciplinary, which is also people from any background can understand.
Of all backgrounds.
Exactly. People can relate easily. They can understand what it means. They can't understand engineering part, let's say mathematical part. But yes, why not? The theme is clear, right?
So research, any kinds of research, needs to have impact. In the end of the day, I guess we owe it to the society to let them know what the hell we're doing. Right?
And this is it comes back to the question that you asked me before, right? it's very sophisticated or the way people do it in the UK, it should be done in other countries as well. Because
Should be
people
done.
need to know. People need to know what it means by research, right?
Right.
What it means, what this topic is doing, what it means actually to us.
Right. Guys, this is more than a pleasure. I know this guy for the last 5 years also. I mean, we've never thought about something like this. It just came out of the blue. And then the opportunity came across and then we did something like this. So wonderful. Thank you very much, Kamal.
Pleasure.
Forever, brother.
Pleasure.
Ciao, ciao, guys. Respect.